Hello friends, welcome back to the another video lecture of ADA subject. In today's video lecture, we are going to learn about our unit number 5, which is greedy algorithm. Okay, so in this video lecture, we are going to learn about introduction of greedy algorithm and an example problem for greedy algorithm. Okay, so let's start with the introduction of greedy algorithm. So, as the name suggests, they are short-sighted in their approach, taking decision on the basis of information immediately at hand without worrying about effect these decisions may have in the future. Okay, so in this thing, greedy algorithm, decisions will be taken on the basis of its information immediately. Okay, we will not worry for the future updates of our problems. Okay, so thus they are easy to invent, easy to implement, and when they work efficiently. Okay, so greedy algorithm are typically used to solve optimization problems. Okay, so by examples we will learn how they exactly works. Okay, so these are the general characteristics of greedy algorithm. With an pseudocode, we have implemented a greedy algorithm example. So pseudocode says we will have two things, first D and N. So in that, D will be domains for different, we can say, activities, or different, we can say, our cases. Okay, so in that, N will be the total number of cases, we can say, or D will be the one domain of that case. After it, we will find a solution. In starting, solutions will be 0. So for finding solution, we will set a for loop. In that, we will start from the I to N. If we are selecting our activity from the domain, then we will set into its S, and if it is found a feasible solution, then we will add that activity into our solution, or we can say our solution set. Okay, so these are the main characteristics of greedy algorithm that we will surely understand by some examples into next video lectures. Okay, so now what are the steps we have to follow for finding the greedy algorithm result? So first, we select some solution from input domain. Okay, after it, we check whether the solution is feasible or not. Solution must be feasible. Okay, after it, from the set of feasible solution, we will find total feasible solution from the given domain, and after finding that all set of feasible solution, we will find a particular solution that satisfy our nearly the object of the function. Okay, such a solution is called optimal solution. Means from the set of solutions, we will find a optimal solution. As a greedy method works in stages, each stage only one input is considered at each time. In this thing, we will not compare and take another solution with some solution. We will go with the single solution with each stage. We have connected, or we have used some other solution in our dynamic programming, but a greedy algorithm will use only single solution, or we can say single input at a single stage. Okay, so this is a general introduction of our greedy algorithm. Okay, now let's understand by an example. So first problem solution we have for greedy example is activity selection problem. Okay, so in activity selection problem, we will have a resource such as CPU and n set of activity such as tasks that want to utilize the resources. Okay, so here you can see the table for this CPU activity selection problem. In that, I is activity, so A1, A2, A3, A4, A5, A6, A7, A8, A9, A10 and A11. So these 11 activities we have. Okay, for all the activities we have two things, SI and FI. Here SI and FI. Okay, so SI is a starting time for I activity, fi is the starting time for fi is the finish time of I activity. Okay, if we select activity 8, then S8 and F8 will be for the starting time for S8 activity and finishing time for the S8 activity. Okay, A8 activity. So an activity selection problem, what is the problem statement? So we will have to find the maximum size subset of mutual compatible activities. Okay, so we will have to find the mutual compatible activities, means if one activity starts and after it completes, then at that stage what activity can be start, and after completing it another activity, what activity can be start. So in this time we have total finishing time 16. Okay, so from the time 1 to 16 maximum how many activities can be done or can be mutually compatible, that is the problem solution for activity selection problem. Okay, so for example, if we start our activity 1 and it's complete at the time 4, so we cannot start our activity 2. Why? Because it's starting time 3 and our first activity is taking time 1 to 4, so 3 is gone, so we cannot start activity 2 after 1. Okay, in the same case we cannot start activity 3 after 1. Okay, so this is the thing, this is we have to consider to find our solutions for activity selection problem. So now let's take its solution. So in the solution steps are given here. Sort fi means finishing time into non-decreasing order. Okay, so here we will sort our finishing time. So our finishing time is 4, 5, 6, 7, 8, 9, means we have done its ascending order. Okay, of finishing time only. Here keep in mind finishing time. Now second step says select the next activity I to solution if set I is compatible with the each activity in the solution set. Okay, now we will take that if we start our activity 1, then its finishing time is 4. So after finishing time 4, that will be we will have to find starting time 4, starting time 5, starting time 6, starting time 7. So minimum starting time 4. So we will find starting time 4 activities here, but we do not have starting time 4 activity here. So we will find for starting time 5 activities. So we have here 1 activity and 2 activities are here. So if we start our starting time activity 5 means activity 4, then its finish time is 7, and if we start activity 6, then its finish time is 9. So in that case our activities we are starting from 8, that will be skipped, that cannot be performed. So from the two cases 5, 7 and 5, 9, we will select our activity 4, which is have starting time 5 and finishing time 7. Okay, so after this activity completes, means first activity complete, fourth activity complete, so now finishing time is 7. So we will check which activity has starting time 7. So no activity have starting time 7. Again, which activity have starting time 8? So here we will have 2 activities 8 and 9 which have starting time of 8, and they have ending time of 11 and 12 respectively. So from that 2 we will select this activity 8 who have finishing time 11. Okay, so now after it we will select which activity who have starting time 11. So no activity is starting from 11. Starting activity 12, no activity from 12. Starting time 30, no activity. Starting time 40, yes, we have activity 11 which have starting time is 14. Okay, so now it will be complete from 14 to 16. Okay, so this is the explanation which I have given already to you. So our answer will be A1 activity, A4 activity, A8 activity and A11 activity. Okay, so this is the maximum activities that we can perform into this given our activity selection problem. Okay, so this is the solution for activity selection problem, and this is the algorithm for finding activity selection. Here we are having 11 activities. A is our starting first activity, I is currently denoted by AI, means our starting activity, means this is I. Okay, and we are starting from the 2 and we are finding a solution. If we find our solution, that we will put into our union, we will put into our solution set, and we will give its finishing time, and after finishing time again we will start our solution finding, and if we find our solution again, then again we will put into our union, or we can say our set. So after completing it, we will find its set as A1, A4, A8 and A11. Okay, so this is activity problem and introduction of greedy algorithm. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you, friends.